Hello everyone and welcome back to the fourth video of Multisim video series, and in this video is continuation of previous video, that is rectifiers, and in this video we are going to know and simulate about full wave rectifiers, that are center tap and bridge rectifier. So this video is all about full wave rectifiers that are of two types, center tap and bridge rectifier. So let's get started. Let's know about what a full wave rectifier. So a full wave rectifier is defined as a rectifier that completes and converts the complete cycle of an alternating current into a pulsating DC output. So as in the half wave rectifier, we were just getting the output for only half of the cycle of input signal, but for full wave rectifier, we will be getting the complete output. And full wave rectifier is of two types, that is center taps rectifier and bridge rectifier. The left-hand circuit that you can see on the screen is of bridge rectifier, which consists of four diodes. The right-hand side of the circuit is center tap transformer, which is having only two diodes. So let's know about how does a full wave rectifier works. So first we will know about center tap rectifier. So basically center tap rectifier consists of two diodes. So in positive half cycle, one of the diode will be forward biased and other will be reversed biased. And through the diode D1, which is forward biased in positive half cycle, we will get the output. And in the negative half cycle, D1 will be reverse biased and D2 will be forward biased. So because of that, we will be getting the output through diode D2, which will work as a ideal short circuit, and we will get our output at resistance R1. So in that case, either of the diode are on in positive and negative half cycle of our input signal. And for the case of full wave rectifier, there are a pair of diodes, that is D1 and D3 and D2 and D4. So when there is positive half cycle of our input signal, D1 and D3 diode will be in forward biased and we will be getting the output at our resistance, that is load resistance RL. And in the negative half cycle of our input signal, the diode D2 and D4 will be in forward biased and D1 and D3 will be in reverse bias, because of which we will get our output through load resistance RL, and in that case we are getting the complete output for both positive and negative half cycles. So this was the complete working of a full wave center tap and full wave bridge rectifier. So there are some mathematical calculations and parameter which one should know. Peak inverse voltage. So it is defined as the maximum voltage across the diode in reverse bias condition. So center tap rectifier, that is full wave center tap rectifier, is having one of the major disadvantage, that it is having a peak inverse voltage of 2 times V max, whereas peak inverse voltage for bridge rectifier is only Vm. Then DC output voltage VDC can be defined as I average into RL, whereas I average is defined by 2 by pi into I max, and RMS value of current can be defined as IRMS equal to I max divided by root 2. And full wave rectifier is having a form factor of 1.11, and the rectification efficiency of a full wave rectifier is 81.2%. The various applications of full wave rectifier are: they are used for signal demodulation purpose, rectification purpose, and signal peak application. And the various advantages as compared to half wave rectifier are there as compared to full wave rectifier, that are having the output efficiency of 81.2%. Then ripple factors, that is number of ripples present in the output DC output voltage. So full wave rectifier is having low ripple as compared to half wave rectifier, that is 0.482. Then output voltage and output power obtained for full wave rectifiers are higher as compared to half wave rectifier. But there do exist one disadvantage of full wave rectifier, that is they need much more components as compared to half wave rectifier, which make this full wave rectifier costlier as compared to half wave rectifier. So after this, we will go to Multisim online simulator and we'll try to simulate full wave rectifier. But before that, if you haven't subscribed to this channel and you haven't watched the earlier videos, then do subscribe the channel and watch earlier videos for better clarification and understanding. So till now we have learned about half wave and full wave rectifiers, and we have already simulated 2 to 3 circuits which were related to some basic circuits, half-wave rectifier circuit. So for this video, I have already designed circuit for bridge and center tap rectifier. And firstly, we will be going to simulate and explore various components for a center tap rectifier. So this is going to be the circuit for a center tap rectifier, which consists of two diodes D1 and D2 that are means industrial IN4007 PN junction diodes, and we have taken a input AC voltage source that is of 22 volt and 1 kilohertz frequency. There is a step down transformer for which we can change primary turns and secondary turns to make the changes in ratio of step down voltage. With that, we our load resistance is connected, which is a 1 kilo ohm. So as we have seen theoretically that whenever the positive half cycle passes through the diode D1 and D2, so in the positive half cycle, our diode D1 will be in forward bias and D2 will be reversed bias. And in that case, the current will pass through diode 1 and will go through our load resistance R node, and we will get output for our positive half cycle. And in the negative half cycle, our diode D2 will be in forward bias and current will flow through D2, and we are going to get our output through load resistance RL in negative half cycle. So in that case, we are getting output for both positive and negative half cycle. So we will select the split mode to get an idea of both the circuit and plot, and we will try to simulate. So this is the simulation going on for infinite seconds. We are going to change its time duration from 0 to 2.5 millisecond to enlarge the graph plot. So this is the graph plot, and green probe is for our output voltage probe and blue probe is our input voltage probe. So in the time duration of 1 millisecond, it consists of both positive and negative half cycle, and meanwhile in that duration, we are getting output for both positive and negative half cycle. As you can focus, you will get a constant zero voltage for a duration of around microseconds. That is because of the cut-in voltage of practical PN junction diode, that is 0.7 volt for silicon and 0.3 volt for germanium diode. So because of that, the PN junction diode operates or conducts only after that specific voltage, that is called cut-in voltage. So this is the practical circuit of center tap full wave rectifier, which is having output for both positive and negative half cycle. We can also export this circuit image, that is schematic image, and graph also. This is our schematic image. This is a schematic image, and in the same way, you can export our graph image, which can be used for some practical observations and some feeding forward to full wave rectifier circuit. With for same, I have designed the schematic circuit and will try to simulate full wave bridge rectifier. So basically, full wave bridge rectifier, which consists of four diodes and one AC input voltage source and one load resistance. So for this circuit, we have taken AC input voltage of 2 volt and 60 hertz frequency, which we can change accordingly as per our requirements and needs. Load resistance is of 1 kilo ohm, and we have connected two probes, that is green probe for input voltage and blue one for output voltage. And there are pair of diodes that are D1 and no, D2 and D3 will be in short circuit for positive half cycle, and D1 and D4 will be going to be in reverse bias for first cycle, that is positive half cycle. And in negative half cycle, D1 and D4 will be in conducting state, and D2 and D3 will be in reverse bias state, as we have learned theoretically. So we will try to simulate and check its graph of plot also. So in the left hand side, we are having our schematic image, and in the right hand side, I have already simulated, so we are going to simulate it again. So this is going to be its output for full wave rectifier circuit. We will change its timing, minimum and maximum timings. And seconds. Yeah. So this is one of the full cycle that is going from 0 to approx 8.492 millisecond positive half cycle, and in the positive half cycle we are also getting output. And in the negative half cycle, we are also getting output through our PN junction diode, and we are getting output at our load resistance. So in that way, full wave rectifier works. We are getting output for both the negative and positive half cycle. So hope this video was clear and you got an idea about schematics related to half wave and full wave rectifiers. And you can go through the previous video also from my channel, and if you haven't subscribed, you can subscribe this channel to get all the videos and alerts whenever I am uploading some new video. Thank you.